Yay! Welcome back. It's Common Core round 3. Ding, ding, ding. And you are the lucky ones. Okay, so here we go. We're going to start off with polynomials. So polynomials, remember, means many and then terms. So we're kind of lying. We're not really starting off with polynomials, but we're going to kind of talk a little bit about them because chapter 1 is all about polynomials. So in the first case here, we have 3 lovely figures. And you see the representation of them in pictures. Well, duh, this is a line. This is a parabola. And this right here is something we saw a little bit back in 8th grade. This is a cubic. Now, what we really want you to know are the equations of these 3 things. So for a line, we have the famous y equals mx plus b. For a parabola, y equals ax squared plus bx plus c. Both of these are very familiar to you. But then the cubic, y equals ax cubed plus bx squared plus cx plus d. Now, let's notice something about these. 1, the highest degree of this is 1. So degree is fancy for the highest exponent. So this is a second degree. The highest exponent is a 2. And this is a third degree. And guess what 3 can also be? That's right, cubic. Later on, we're going to see some other things that these degrees tell you. Some of you may remember it tells you how many times it should cross the x-axis. So a line could cross the x-axis once. A parabola could cross the x-axis up to 2 times. And a cubic could cross it up to 3 times. But we're getting ahead of ourselves. For today, we want you to figure out if something is a line, a parabola, or a cubic. We have 3 examples here. Shocking! We talked about 3 different things in the beginning. Bet you one's going to be a line. Bet you one's going to be a parabola. I bet you one's going to be a cubic. Anyway, we have now just given you points. We could graph these and see what shape it makes. And then we'd be able to tell if it's a line, a parabola, or a cubic. But there's something called the common difference, which is going to take a lot shorter to do. So in each example, the first thing I'm noticing is that the x values go by ones. 0, 1, 2, 3, 4, 5, 6. Beautiful. So where is the common difference coming? It's coming in the y values. So for this first example, 5 minus 2 is 3. 8 minus 5, skipped one there, is 3. 11 minus 8 is 3. 14 minus 11 is 3. 17 minus 14 is 3. 20 minus 13 is 3. Okay, stay with me. See if you can figure it out, because I know you can. Let's go on to example 2. Once again, I notice the x values are 0, 1, 2, 3, 4, 5, 6. Okay, they're going in order. We like that. Now let's look at that common difference again. 2, 0 is 2. 10 minus 2 is 8. 24 minus 10 is 14. 44 minus 24 is 20. 70 minus 44 is 26. 102 minus 70 is 32. I don't have a common difference like I had here, which were all 3s. But wait a second. Look what happens here. 8 minus 2 is 6. 14 minus 8 is 6. 20 minus 14 is 6. 26 minus 20 is 6. 32 minus 26 is 6. Interesting, rabbits. Let's take it a step further to example 3. Once again, I see my x values go 0, 1, 2, 3, 4, 5. Lovely. Now, 1 minus 2 is negative 1. 6 minus 1 is 5. 23 minus 6 is 17. 58 minus 23, let's see, that's 5, 35. 117 minus 58, gotta do a little something in my head here, is how I add. Let's see, 42 brings me to 117, so that is 59. All right, careful now. 5 minus a minus 1 is 6. 17 minus 5 is 12. 35 minus 17 is 18. And 59 minus 35 is 24. I'm going to run out of room here. 6 minus 12. Let's make this a little thinner. 6 minus 12 is 6. 18 minus 12 is 6. 24 minus 18 is 6. Can you put it all together? I mean, I told you we've got an example of a line here. We've got an example of a parabola, and we've got an example of a cubic. Which one is which? Well, it makes sense. We go back to these degrees now. Remember, a line had a degree of 1. A parabola, its highest degree was 2, and a cubic, its highest degree is 3. And likewise, look what example 1 is. Example 1 is a line, because we only had to go 1 level or 1 degree to find a common difference. Example 2, you got it, is a parabola, because we had to go 2 levels to find a common difference. And obviously the third one is the cubic, because we had to go 1, 2, 3 levels to find a common difference, thus a third degree equation. Now, the next thing we're going to ask you to do is to find the equations. So the line shouldn't be that hard to do. You should remember how to do a line. Y equals mx plus b, because this common difference tells us the slope is 3. And then we have the y-intercept, right? When the x value is 0, it relieves the y-intercept of 2. So finding the equation of a line by now should be very, very quick. We notice we can pick any point. Let's say we pick the point 5, 17. 3 times 5 is 15, plus 2 more is 17. It works. Now for a parabola and a cubic, I'm going to get a little lazy here. I'm just going to go back to my friend the calculator. All right, now you may not remember this from last year. I know you did it with Mr. Kinnear, and we did it in 8th grade, but to do a regression means we're going to put the points into the calculator and let the calculator figure out the equation. So the first thing we're going to go to is our stat key. Notice here it's in red. So you may want to write down these steps if you don't remember them. Now we're going to go to 1. We want to edit our lists. So we've got list 1 and list 2. Those are our x and y values. So it started off 0, 1, 2, 3, 4, 5, 6. And then we pop over to the next list and we put in the y values there. 0, 2, 10, 24, 44, 70, and 102. Now, we go back to stat. Now we can calculate, and all our regressions are listed here. Since this was a degree of 2, we are going to choose number 5, a quadratic regression. It's asking us, are our x values in list 1? Yep. Are our y values in list 2? Yep. You should have nothing in frequency list. If there is something there, clear it out. We don't have to store our regression. Calculate. Boom. There it is. They even give you the equation of the quadratic, just in case you forgot it. And then a is 3, b is -1, and c is 0. So if we were to write this out, our equation would be y equals, already forgot the numbers, 3, -1. 3x squared minus x, and there was no value. That was a +0. You don't have to write the +0. That's your equation. And again, you can pick any point and it'll work. I'm going to pick an easy point. I'm going to put 2 in there. 2 squared is 4. 3 times 4 is 12. 12 minus 2 is 10. Bingo. All right, so for the cubic, it's the same thing. I'm going to go back to stat. I'm going to edit my list out. Now I've got to clear out my old points. So I don't have to clear out my x values. They're pretty much the same except for 1 point. Remember, I go up so that I'm over list 2, and I press clear. Do not press delete. If you press delete, list 2 goes bye-bye. You delete it. You just want to clear it. Then I press enter. All right, so what are my values here? 21623, 21623, 58, 117. But I also have this 6 over here. I've got to delete that 6 out of there. I'm going to go back to stat, calculate, but this time I'm going to choose number 6, a cubic regression, because we went down 3 levels. And there's my equation. Now look at this b value here, -6e -12. That is how your calculator does scientific notation. That number, if I were to write it out, is this. 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is in essence the number 0. So we ignore that. We have to realize that that is the number 0. And our equation is y equals a is 1, b is 0, c is -2. 1, 0, -2, 2. 1, 0, -2, 2. And once again, we really don't need to write that term. That is our cubic. And again, if we pick a point, if I pick 2, 2 cubed is 8. 8 minus 4 is 4, plus 2 is 6. It checks. But with Common Core, the last thing I want to look at and remind you is we're not always going to have numbers. This says show that the second difference is equal to 2, given that we're using our x values as n, n plus 1, n plus 2, n plus 3, and n plus 4. Well, we know that the second difference has to be a constant because it's a squared going on. So the first problem, if I put an n in for x, well, n squared is quite obvious. But do you remember how to square a binomial quickly. So remember, n plus 1 squared is n plus 1 times n plus 1. N squared plus n plus n plus 1. N squared plus 2n plus 1. Well, guess what? Remember, that takes too long. And I did teach you in 8th grade a short way to square any binomial. If you remember, it's square the first term, square the last term, and then multiply those together, get 2n, but you double it to get 4n, because we end up having 2 of them when we double distribute. And remember, we joked around and we said it looks like glasses? Or we could do n, square the first, 3, square the last. Some of you are like, well, no, we wanted to make a smiley face. 3n doubles to 6n. Square the first, square the last. Smiley face because math is awesome. 4n doubles to 8n. All right, well, now that we've got our y values, what the heck did they want us to do with our values? They wanted us to show that if we took a difference, the answer would be 2. Well, n squared plus 2n plus 1 minus n squared minus n squared cancels out. We have 2n plus 1. Basically, that's going to happen down the line. N squareds cancel out. 4n minus 2n is 2n. 4 minus 1 is 3. N squareds cancel out. 6n minus 4n is 2n. 9 minus 4 is 5. N squared minus n squared cancels out. 8n minus 6n is 2n. 16 minus 9 is 7. But they said second difference, which means I've got to go down yet another level. 2n minus 2n cancels out. 3 minus 1 is 2. 2n minus 2n cancel out. 5 minus 3 is 2. 2n minus 2n cancels out. 7 minus 5 is 2. Proven. All right, here's your lesson summary. We can determine the equation of a polynomial from a set of ordered pairs by finding successive differences. For every level we must go down determines the highest degree of the polynomial. We end when we have a constant difference. We can then use the related regression on our calculator to help us find the proper equation. And the school year begins.